Welcome to the chemistry class. We are in chapter Ionic Equilibrium, session 5 and 6. In this session, we will introduce what is common ion effect and what are its applications and what are buffer solutions. So the aim is to introduce common ion effect and to introduce buffer solutions. Buffer solutions. Now what are these buffer solutions? Let us take an aqueous solution of a substance. So this is solution 1, aqueous solution of a substance. Then what is its pH? Let us use the pH meter and find out the pH value of this solution. And the pH is shown by this pH meter as 4. So the pH of this solution is 4. Let us take now the same solution once again. This is also solution 1, same solution. Let us now add some amount of strong acid HCl. So HCl is added few ml into the solution 1. Now with the addition of HCl, the H plus concentration in the solution becomes more, and let us see what is the pH of the solution by using the pH meter. Now the pH meter reads the pH as 3. Therefore, after adding HCl, pH of this solution has reduced to 3. That is a change in pH of 1 unit by adding small amount of strong acid HCl to the original solution. Let us now take once again the original solution 1. This is also solution 1. Let us now add few ml of strong base. So strong base NaOH is now added. Now the pH of the solution is 5. What is that we can understand from these experimental results? So the aqueous solution of substance which is having pH originally 4, which is showing a decrease in pH of 1 unit and addition of few ml of a strong acid. That is, this solution shows appreciably large change in pH by adding strong acid. Similarly, when we add strong base NaOH to the same original solution, the pH is increasing by 1 unit. That is, with the addition of few ml of strong base, the solution is changing its pH by large amount. Therefore, this solution 1 is showing large change in pH on addition of few ml of either strong acid or strong base. Let us now take a mixture of acetic acid and sodium acetate, and this solution now contains acetic acid molecules, acetate ions, H plus ions, Na plus ions. Let us see what is the pH of this mixture of acetic acid and sodium acetate by using pH meter. Now the pH of this mixture is 4. Let us add few ml of strong acid to this acetic acid acetate mixture. Now addition of HCl is taking place. After few ml of acid is added, let us now observe will the pH remain same or changes. If changes, by what amount? Now it has come down to 3.94. Thus, a small change in pH is taking place on addition of few ml of strong acid. Now take once again the original acetic acid acetate mixture. Now let us add small amount of strong base and let us find out once again the pH of this mixture. Now let us add few ml of strong base NaOH. Now let's check what is the pH of this solution after the addition of NaOH. Now the pH has come up to a value of 4.06. Now let us compare. In the beginning the pH of the solution was 4. After the addition of few ml of strong acid, it has decreased by a very small amount to a value of 3.94. So a small change in pH took place even on addition of few ml of strong acid. But what happened in the last case? When few ml of strong base NaOH is added, the pH is increased but by a very small amount comparing to the original pH of 4. In other words, this solution is changing its pH by a negligible amount when small amount of strong acid is added or small amount of strong base is added. Such a solution which maintains a fairly constant pH or such a solution which maintains pH almost same even on adding few ml of strong acid or strong base is called buffer solution. So how do we define this buffer solution? A solution whose pH is not altered to great extent. Means a negligible change in pH can take place but not by large amount on addition of small quantities of either strong acid or base, then it is called buffer solution. Or a solution of reserve acidity or alkalinity which resists change of pH upon the addition of small amount of acid or alkali is called buffer solution. Now let us discuss the characteristics of buffer solution. 1. A buffer solution will have definite pH. For equimolar concentrations of acetic acid and sodium acetate buffer, say with a pH of 4.74, it will maintain this pH. The second characteristic, the pH value of the buffer solution does not change on long standing. Means the above buffer, if kept for long in open air, it will keep its pH value fixed as 4.74 itself. Let us see this with an example. Let us take certain amount of pure water in a beaker, and since it's pure water, its pH is 7 as shown by the pH meter. Let us now take some amount of pure water in the beaker and expose it to atmosphere. This water absorbs carbon dioxide from atmosphere, and thereby water reacts with this carbon dioxide forming carbonic acid. So if you see after few days, what is the pH of this water? So it is now found to be 6.4. In other words, less than 7. That it has become acidic in nature. How? This water is reacting with the carbon dioxide that is being absorbed slowly from the atmosphere in few days of time, forming carbonic acid. It is indirectly now a dilute solution of carbonic acid. Hence it is having pH of 6.4. What do we understand from this? In case pure water is exposed for longer time to the air, it absorbs carbon dioxide and change in the pH value. But whereas if you take buffer and expose it to air for longer time, even then you find the pH value remaining constant. That is, buffer solution does not show any change in pH even when it is exposed to air or even if it is kept open for long time. Now, will the pH value of the buffer solution changes on dilution? pH does not change on dilution. That is, let us take 1 liter of above buffer and add 1 liter of water. Now the total volume of the buffer becomes 2 liters. Even in these 2 liters, the concentration of acetic acid and its base conjugate remains same. Therefore, buffer will maintain its pH to be 4.74 only. Now fourth characteristic property for buffer mixtures. Will the pH of the buffer change when we add small amount of an acid or small amount of a base? The buffer will show a small change, or in other words, negligible change in pH on addition of small amount of strong acid or strong base. In other words, even after adding small amount of strong acid or strong base, the change in pH being very less, neglected comparing to original value. Thus we say pH is either slightly changed or indirectly it maintains a fairly constant pH even on adding small amount of strong acid or strong base. Thus what do we find the characteristics of a buffer solutions? A buffer will have a definite pH, that is, it has reserve acidity or alkalinity. Its pH does not change on standing. Its pH does not change even on dilution, and pH is slightly changed when small amount of strong acid or strong base is added. These are the characteristics of a buffer solution.